Good afternoon. My name's Jim Bell. I'm the Managing Director of FoundOcean, and I've been with FoundOcean since about 2005. And the company itself has been around much longer than that, so I can give you a brief history of how we started and how we ended up in offshore wind. But first of all, I'd just like to point out that we're a global company. We have our headquarters in Scotland near Edinburgh. We also have a base in Houston in the US, a base in Batam, Indonesia, close to Singapore, and also a base in Mumbai, India. Now, we started in the 1960s as part of a large UK construction group called Wimpey Construction. And it was there that we developed the concept of offshore grouting for the oil and gas industry in the 1960s. And that work continued all the way through the 70s, 80s, 90s, and a little bit up until today, although that market, as we're all aware, is diminishing as we're making the energy transition to offshore wind. Now, we started in offshore wind in 2003 when we grouted the Bank wind farm in Ireland, working together with Density using one of their Do-Grip products. Since 2003, we've grouted more than 2,000 offshore wind foundations. 2010, we grouted the Ormond wind farm. That was one of our proprietary grout projects that we did, the Ormond wind farm using OPC. 2016, we worked together with BASF as they then were to develop their Masterflow 9800 product, which got away from the need to use big bags to deliver the material. And then significantly in our history, in 2021, we joined the Ventera Group. Now, the Ventera Group was set up specifically to pull together a group of companies who all provide services into offshore wind construction. And their aim is really to help the offshore wind industry grow globally. And since we've become part of the Ventera Group, this has really helped us to grow, develop, and invest more in the business. Now, there's quite a lot of detail in this presentation and quite a number of slides. I'm not planning to go in to explore all the detail on every slide, but I will sort of skip over some of it, but the information's there for you to look at in more detail should you need to. And of course, you're always welcome to ask questions later on. So, what do we do? Well, we're an offshore grouting company, and I'd say that 80% of our revenues and activities are derived from grouting offshore foundations subsea, and 90% of that is in offshore wind these days. We also get involved in strengthening, modification and repair of offshore assets, and often this work can be strengthening assets in preparation for decommissioning in the case of oil and gas. Other assets where they're aging, we have various solutions, repair clamps and member filling methods to strengthen aging or damaged structures. And then we provide some products. I mean, we're mainly a service business, but we also provide some products such as some ROV grout connectors, which allow grout hoses to be connected to the grout inlets on structures subsea, which avoids the need for fixed pipe work. And we manufacture fabric formworks, also known as grout bags, which are used to support, stabilize and protect subsea cables and pipelines. So offshore grouting is certainly well established, well adopted in the offshore construction industry, for the simple reason that grout is extremely good at filling voids of uneven shape, varying size, and locking together pieces of steel and providing a strong bond between surfaces. And for that reason, it's been used for many decades in offshore construction. Now, we're all familiar with the main types of foundations in offshore wind. There's the jacket foundation, multiple piles connected to a lattice structure. The monopile, probably the most common offshore structure that is used in offshore wind these days. Gravity base, and I'd also add suction anchor to that, which is typically spreads the load of the structure without a pile into the seabed, and then of course the floating structure, which is beginning to emerge in various markets and locations around the world. So with jackets, gravity skirt piles, this is quite unusual. More often the piles are pre-driven than post-driven, and that's the case. Pre-driven piles for the grouted pin piles, where the bottom of the jacket is inserted into the top of the pile, and then occasionally suction caissons. Those can be used sort of associated with gravity base, or for jackets. We're working at the moment on the Seagreen project, which is using a combination of suction caissons and jackets. Monopiles. Various different ways of constructing those. A standard grouted TP, a TP which includes a bolted connection, then some grouting to provide to prevent water ingress and provide protection and stiffness to the pile. Fully bolted and ungrouted. Monopiles, again ungrouted, without TPs, where the turbine tower is bolted directly to the top of the monopile, and then a suction bucket version of the monopile, which is fairly unusual at the moment. The gravity-based structure, just usually made out of concrete, sits under its own weight on the seabed. This is an approach that's been used in northern France recently, and probably 20 years ago in Denmark. And then the floating structures, where you have most of the debate at the moment is around the tethering methods. So there's grouted anchor solutions, ungrouted anchors, and the monoblock, i.e. manufactured in a single unit, or modular assembly that we've seen, where smaller fab yards can make pieces that are then brought together to a final assembly point near the installation site, and those components are grouted together to make the overall floating structure. Now, different types of grout, ranging from extremely weak to extremely strong. The weakest grouts, less than 5 megapascals, are typically used in suction anchors or underneath gravity-based structures. At the top end, there are the ultra high strength construction grouts, which are often used in monopile transition pieces. And then in between, we have a range of grouts of different types. Some are proprietary construction grouts, others are standard OPCs or OPCs with admixtures that are often used in jackets or in monopiles, as in order to prevent water ingress, where less ultimate strength is required. Now, we've worked with almost all of the available grout types that are used in the industry these days from the various manufacturers, and you can see here that apart from the lowest strength grout, the manufacturers offer a range of products that cover various applications, from sort of around 70 megapascals all the way up to 130 or even 150 megapascals in some cases. The applications of these grouts vary. I mentioned it briefly earlier, but generally the suction caissons use the weakest grouts, and the grouted skirt piles use the strongest grouts. And then when you consider monopile foundations, there isn't really any application for the lower strength grouts, but the higher end, the fully grouted TPs do use the ultra high strength grouts from a range of manufacturers. Now, All of this is very well, but the important thing is to bear in mind how you are going to get your ground products to the construction site. The difference between oil and gas projects and offshore wind projects is the number of structures and the sheer quantity of materials involved, whether that's going to be delivered all in one go, delivered periodically during the course of the project. You've got to consider the shelf life of the material, how quickly it'll be consumed, what approval types are required by the certifying authority or by the client or by their insurer. So there are a lot of choices to be made in terms of material type, and then the logistics of delivering it to the work site. In the marketing yard, sufficient space is required to set up perhaps a tank farm. Also, in considering the supply chain, it's important to know where the material is being manufactured. Now, at the moment, most grouts are made in Europe, although some manufacturers are now beginning to bring manufacturing facilities on stream in Taiwan, which is extremely beneficial and cuts down on risk and time in the supply chain. And if OPC can be used, then this is generally available in most parts of the world, or in fact all parts of the world. So that's a much easier product to get hold of. Offshore again, how are you going to handle the product? Is it going to be in bulk, where it can be pneumatically delivered to the ground mixer, or will it be delivered in big bags, which will require craneage to lift it into the ground mixer? Now, big bag material can be more difficult to store. Often it needs to be stored in climate controlled and watertight warehouses, whereas bulk material can be stored in its silos in the open air, because the silos themselves provide the protection from the elements. And shelf life. Most proprietary grouts have a shelf life between 6 and 12 months, depending on how they're stored and transported and delivered. OPC has a similar shelf life, but is available at much shorter notice. And there was one occasion on a project where a large quantity of construction grout had to be disposed of because of a significant delay in the offshore construction program. And different mixer types, different types of grout. But grout in big bags would be mixed in a pan mixer. That's a forced action mixer, whereas material in bulk is generally mixed in a recirculating jet mixer, which is well-established technology dating back to the 1970s, and that tends to have a much higher output rate, partly because the delivery rate of the dry material to the mixer and also the mixing process itself. And for most jacket-related projects, the recirculating jet mixer using bulk material is utilised, whereas the big bag ultra high strength material tends to be used on monopiles. And again, another important question is whether the client, the designer, the insurer, the certifying authority require the material to have a DNV type approval certificate, or whether track record experience of previous projects is adequate. And this will be important in making the selection of the material. And often, if a new material is considered, or a non-DNV approved material is considered, then DNV will often work with a project if there is sufficient time in order to qualify that material for a given specific project. So why is one material preferable over another? I think this is quite an important consideration, perhaps one of the most important things to consider in terms of determining your material selection. How will it be handled offshore? Will the delivery of materials to the mixer require a crane that may tie up the vessel crane during grouting operations. Water type, most construction grouts require fresh water. OPC can be mixed with seawater, and fresh water is a much more scarce commodity offshore, so supplying large quantities needs to be planned for. And generally the mixing process is faster with a bulk supplied material. So there are a number of considerations which appear to favour the bulk delivered material, but then on the other hand, you will always get a much higher, at the moment, materials that are available, you'll get a much higher grout strength for material that's delivered in big bags, so the ultra high strength material. But handling big bags offshore is complicated, and storing them requires some additional considerations. So, a case study. I thought it'd be worth looking in a little bit of detail at one of the major wind farm projects that we worked on in the last few years. That was the Beatrice wind farm. And in fact, in this image here, you can see our 100-ton bulk cement tank sitting on the back of Seaway heavy lifting Zolag Strashnov construction vessel, and in the water just to the foreground is the yellow jacket structure of one of the foundations. Now that project, slightly more than half a gigawatt of installed capacity, enough for nearly 500,000 homes in the UK, located in the North Sea, so quite a difficult area to work in particular in the winter. And the main investment partners were Copenhagen Infrastructure Partners, Scottish and Southern Energy, and Red Rock Power, jointly formed Beatrice Offshore Wind Limited. Now we provided the grouting services offshore and also the onshore logistics for the 84 turbines. And what was important, for this project, it was the first time a high strength material was stored and transferred via silos all the way through the supply chain, and this was important in delivering the project on time. And also we deployed on that project for the first time a super recirculating jet mixer to provide a faster mixing experience. Now that mixer has been used on numerous projects since then, and in fact we have subsequently developed even faster mixing systems. So the foundation, four-legged jackets, pre-installed piles, and pins at the bottom of each jacket leg that were inserted into the piles, and grouting was done through grout lines that were pre-installed and ran all the way to the top of the structure, so that side of things connecting the grout lines was relatively straightforward from the top of the jacket. Now the material selected was Masterflow 9800. Had to be supplied in bulk to at least it would not have been possible to store sufficient material in big bags on the back deck of the construction vessel. It was only possible to store about 800 tons, so it was quite important to have a continuous flow of material through the supply chain. There was also storage of only a couple of thousand tons at the supply base at the supply base dockside marketing yard in Rotterdam. So it was important to have a sort of a not quite a just-in-time delivery, but a carefully planned flow of product from the factory through the marketing yard to the offshore site. Total material required 12,300 tons, just over 140 tons per structure, and on average, when we were grouting, we grouted 3 jackets in a 24-hour period. QA, of course, is absolutely vital, and across the project, we took more than 6,000. Took and tested more than 6,000 grout cubes. And here you can see our onshore storage facility at Rotterdam dockside. So the material was shipped from Germany to Rotterdam stored in these silos that you can see in the photograph, transferred to a supply vessel, which then steams to the offshore construction location and was transferred again pneumatically to the silos on the back deck of the construction vessel. And in order to keep track of the material batches, which is vital for effective quality assurance, we've developed an online batch tracking system called Batch Tracks, which follows from factory through supply chain into the skirt pile, each individual batch material that's used on the project. So, as I said, I've skipped through those slides fairly quickly. There's more detail on them should you want to study them. But if that does, if this does throw up any questions, then please get in touch. Was available to ask questions, to answer questions. And you can be sure that if you have a scenario in mind, it's more than likely that we've seen it before and executed a project which includes it. So I'd be delighted to ask any questions that you may have. Thank you very much.